Hi, welcome to the tutorial on functions. By the end of this topic, you will be able to explain and implement functions. Functions is one of the simplest yet among the most powerful features of any programming language. To understand functions, let's go through this simple example. During my early days as a college student, I used to wash my clothes every other day, and steps to wash my clothes were typically the same. That is, soak the clothes, wash them, rinse them, and dry them. Doing these repetitive steps every other day took a considerable amount of time. So later on, my friend and I contributed to purchase a washing machine. All it needed as input were the clothes, water, and some information like washing duration, etc. All the steps that we used to perform manually were now being handled by the washing machine. Now, you might be thinking how this example relates to function. The washing machine in the example is analogous to the properties of a function. A function is like a small program which handles a specific task. Like washing machine, it requires some input, according to which it performs the task it was designed for and returns a result. Now, you might be asking, why do we need functions? Functions allow us to reuse the code efficiently so that we don't have to rewrite code over and over again in a program. We can easily call a function anytime and it will perform its assigned task. There are essentially two types of functions: predefined functions and user-defined functions. Let's discuss each of them one by one. We will start with predefined functions. We have already seen the sum function before. It calculates and returns the sum of any list so that we will have to write code for calculating the sum. Similarly, we have seen the max function in NumPy. And we have also seen the minimum function. Predefined functions are mostly available to ease the use of programming language and also to avoid writing code for the trivial operations. But sometimes we need to perform an operation frequently which is not predefined by the Python or any other library. That is where the user-defined functions come into play. Let's discuss user-defined functions now. User-defined functions are defined by the user according to their needs. Syntax of a function looks like as shown on the screen. Def here is a keyword which tells Python that we are going to define a function followed by the function name. Note that this line also ends with a colon, which means that the following indented lines will belong to this function. Inside the brackets are the input parameters which we need to provide for a function to work. It is similar to setting a timer for the washing machine. Using the information provided as the parameters, the function performs a specific task. You should note that a function may or may not return something. Let's see how it would look like in Python. We will first define a function to return the square of a number. In this case, our function underscore name is square and the input parameter is the number a of which we want to find the square of. In the third line, we are returning the square which has been calculated by the function. In the fifth line, we are calling the function by its name and supplying 5 as the input value. When we run this cell, we will obtain 25 as the answer. Now let's look at another problem statement to understand how functions allow us to reuse code efficiently. During our high school days, we studied in mathematics about the concept of combinations. Its formula was given as CNR is equal to n factorial divided by r factorial into n minus r whole factorial, where n represents the total number of distinct objects and r represents the number of objects to be picked. The combination CNR represents the number of combinations in which r things can be picked. Given n equals to 10 and r equals to 6, calculate CNR using Python. We will first solve this problem using the traditional way without using functions. To calculate the combinations, we first declare the value of n and r as 10 and 6 respectively. Now we calculate the factorial of n using the concept of loops, which we saw recently. Similarly, we calculate the factorial of r and factorial of n minus r. Once we have calculated all the three values, we feed these values to the formula of the combinations to calculate and print the result. The answer came out to be 210, which is right. But did you notice something? We have applied the same logic using the similar code over and over again. Now let's solve the problem with the help of a function. Nice. As you can see, this code looks cleaner and concise when we used functions. During the previous implementation, we calculated factorial of n, r and n minus r individually. In this implementation, we first defined a function to calculate the factorial of any number, and then we used this function to calculate factorial of n, r and n minus r to get the required result. With this example, you can see the benefits of using a function such as reusable, concise, and more comprehensible code. Here, we have used an extremely simple example to demonstrate functions. But in the real world, functions are used for complex and repetitive operations, some of which we might even see later in this training. So that's all in this topic. In the next topic, we will be looking at basics of data exploration.